Breaking news. Breaking news from the quiet corners of our own sky. Something has been following an interstellar visitor into our solar system, and no one outside the astronomy world has heard about it. Night after night, observers staring at faint images of 3I Atlas began to notice a pattern that felt more like a shadow than a coincidence. The object itself is strange enough. A fragment from another star system racing through our neighborhood, brightening faster than anyone expected. But behind it, beside it, and in front of it, small points of light kept appearing, disappearing, and reappearing along the same celestial roadway, as though the visitor was not traveling alone. At first, these faint companions were easy to dismiss. The sky is full of rocks, icy fragments, background galaxies, noise in the cameras, tricks of exposure and processing. Astronomers are trained to be cautious, to assume error before intrigue. Yet as more data came in from widely separated observatories, a faint pattern refused to vanish. Some of the points shared almost the same motion as 3I Atlas. Some drifted ahead of it like scouts. Others lagged behind as if reluctant to let it go. In data plots and stacked images, a soft, unsettling idea began to form. What if this is not a solitary wanderer at all, but the brightest member of a small, loose gathering moving together through space? That is where tonight's story begins, with a simple, unnerving possibility. For the third time in human history, we are watching an object from another star system cross into ours. Only this time, it may have company. A faint, scattered swarm that could be debris, fragments, co-traveling bodies, or something entirely different. From a distance, the details blur together like grains of dust in a beam of light. Up close, every grain might have its own history, its own path, its own clue about what happened long before these objects ever reached our sun. In the hours ahead, we will slow down and walk along this path together. We will follow the data from the first hints of a companion object hiding in the noise, to coordinated observing campaigns that try to catch every speck moving with 3I Atlas. We will ask what it means when a visitor from another star arrives in what looks like a small convoy, and why that idea makes even cautious scientists shift in their chairs. Is this simply what happens when a fragile body spends millions of years being chipped and battered between the stars? Or are we seeing the fossil evidence of some ancient breakup event that happened far away under another sun? Along the way, we will step back and remember what 3I Atlas already is without any companions at all. A body on a hyperbolic trajectory, moving too fast to stay. A nucleus that has grown an atmosphere larger than planets. A traveler whose chemistry refuses to match our models, whose brightness curve rises above our predictions, whose tail sometimes appears to point the wrong way. Add to that a possible entourage of smaller objects pacing it through space, and the picture becomes even more unsettling and more beautiful at the same time. Tonight's exploration will not promise monsters hiding in the dark or secret machines lurking in the sky. Instead, it offers something quieter and, in ways, more profound. The chance to understand how fragile ice and rock from another star system behave when they finally fall under the spell of our sun, and what that behavior reveals about the places where they formed. If there truly is a swarm traveling with 3I Atlas, then every fragment is a message written in temperature, pressure, gravity, and time. As you listen, imagine the solar system as a great, slowly turning stage. On one side, our familiar planets move through their orbits, steady and predictable. On the other, from the dark beyond Neptune, a fast-moving actor cuts across the scene on a one-time pass, and somewhere around it, barely visible without careful attention, a small cloud of fellow travelers drifts in loose formation. No one on Earth arranged this encounter. No mission planner set this up. We are lucky enough to be watching at the right moment. Stay with this story until the very end, and you will learn what the best data so far actually say about this suspected swarm. You will hear how astronomers test whether 2 points of light are truly moving together or only appear aligned by chance. You will see why some researchers now speak cautiously about comotion and clustering around 3I Atlas, while others remain skeptical and ask for stronger proof. And you will discover why, for many of them, the most exciting outcome is not that something has been deliberately sent, but that nature may have delivered an interstellar convoy all on its own. For now, all you need to do is settle in. Let the day soften behind you, and let your imagination follow this visitor and whatever may be drifting beside it. Somewhere out there, far above the red deserts of Mars and the blue glow of Earth, 3I Atlas is still moving. If a swarm has indeed been following it into our solar system, then tonight we will trace their paths together and see what their quiet presence can teach us about the wider galaxy beyond our sky. If you want to understand how astronomers judge the behavior of a comet, you do not start with dramatic photographs or long scientific papers. You start with a simple line on a simple graph, a light curve. It looks humble, just brightness plotted against time, but it has a quiet power. It shows what the object is doing, even when we cannot see it clearly, even when telescopes disagree or the weather gets in the way. The light curve is the comet's heartbeat, and for most comets, that heartbeat follows the rules. As they approach the sun, they brighten in smooth, predictable waves. As they move away, they dim just as gently. But 3I Atlas was never going to follow those rules. To make sense of why its behavior surprised so many scientists, we can step back and understand what astronomers actually mean when they talk about brightness. They use a scale called magnitude. Lower numbers mean brighter objects, and higher numbers mean fainter ones. A star of magnitude 1 blazes in the sky. One of magnitude 6 sits at the edge of what the unaided human eye can detect. Beyond that, the scale climbs quickly into numbers that require binoculars, small backyard telescopes, or large professional observatories. A change of even 1 magnitude is a big deal. It means the object has not merely brightened a little, but enough to stand out to anyone watching closely. Think of it this way. If the night sky were a dark room, magnitude 1 would be a bright flashlight. Magnitude 6 would be a candle at the far end. And magnitude 16, the brightness of 3I Atlas when it was first spotted, would be a tiny LED lost in the distance. You would never see it without training your eyes and your instruments to look for something almost invisible. In the early days of observation, 3I Atlas behaved exactly as the textbooks predicted. Its magnitude crept upward, slowly becoming easier to detect, just like a normal object responding to sunlight as it neared the inner solar system. Astronomers watched with quiet satisfaction. Another interstellar visitor, yes, but at least this one seemed to be following the expected script. At first. Then, in a handful of nights, everything changed. The light curve refused to obey the models. Instead of climbing along the gentle slope that theory predicted, it jerked upward in a spike, brightening far faster than the most generous forecasts allowed. It was as though someone turned the dimmer switch, not a single notch, but halfway up. Observers recalibrated, double-checked, stacked images, compared notes. The spike remained. The comet was misbehaving. That spike was the first serious hint that something unusual was happening inside 3I Atlas. Comets brighten when sunlight warms their surfaces, releasing volatile materials, frozen carbon dioxide, frozen water, carbon-rich molecules that blow out as gas and dust. This material forms an enormous hazy atmosphere called a coma that reflects sunlight. If the coma thickens, the brightness jumps. For a typical comet, this process follows a smooth rhythm. For a fragile interstellar object, the process can be violent. The most likely explanation for the sudden surge was a burst of activity, jets of gas erupting from fractures in the nucleus, or pockets of frozen material suddenly exposed to heat after perhaps millions of years spent drifting in cold interstellar space. That kind of eruption does not happen quietly. It usually means the interior is unstable, with pressure building behind weak walls of dust and ice. Sometimes the result is a controlled release. Sometimes it is a fracture, and sometimes the object simply splits apart, sending fragments scattering like shrapnel into the dark. As scientists studied the light curve, they could almost imagine the interior landscape of 3I Atlas groaning under stress. A comet is not a solid rock. It is a patchwork structure, part ancient dust, part frozen gas, part delicate architecture held together by low gravity and colder than anything on Earth. When heat finally reaches into those layers, the result can be surprising. It can be beautiful. It can be the first sign that the object is approaching its limits. For 3I Atlas, the timing of the brightness surge raised eyebrows, because it happened just as the object was approaching the region of space where its path would sweep near Mars. The increase in brightness was not only unexpected, it was inconvenient. Telescopes on Earth were watching more closely during that time. Missions around Mars were beginning to consider their best opportunities to observe. And just as attention turned toward it, the comet shifted into a higher gear, behaving as if something inside had woken up. Imagine watching a heart monitor on a patient who has been stable. The line rises and falls in a steady rhythm. Then, suddenly, there is a spike, a sharp, unmistakable sign that something inside has changed. That is how the brightness data looked to the teams tracking 3I Atlas. The comet was telling on itself. A veteran astronomer once described it perfectly. The light curve is where the lies stop. If the comet is misbehaving, the brightness will tell on it. Was this simply the natural release of gas as sunlight warmed new layers? Or was it the beginning of structural stress? No one could say with certainty. But the timing meant one thing. Whatever was happening inside 3I Atlas, it was happening right as the visitor was preparing to cross a part of the solar system where multiple spacecraft had a chance to observe it. That raised hopes and tension at the same time. If the activity continued, the comet might offer spectacular views. If it escalated too far, it might simply break apart before the moment of closest opportunity arrived. Astronomers are trained to read patterns in data, and this pattern was clear. The brightness curve was no longer a gentle slope. It was a ramp, accelerating upward. That kind of behavior almost always means the comet is shedding material more quickly than before. The coma grows thicker, dust spreads farther. Jets carve new shapes. This expanding cloud makes the comet look larger and more dramatic on approach, but it also means the nucleus is under strain. For our purposes tonight, one detail matters most. The surge in brightness was not an isolated event. It was part of a sequence, a story unfolding across millions of miles of space, and its most dramatic chapter was still ahead, when 3I Atlas would graze the orbital neighborhood of Mars with an unstable interior and a growing halo of gas and dust. The data hinted at a fragile object, a dynamic object, a visitor carrying the marks of a long and difficult journey. If you follow that data forward along the graph, you can almost feel the tension rising as it heads toward the part of space where the red planet waits like a witness. So, where did this misbehaving visitor come from? And how did it end up threading the needle so close to Mars? To understand why 3I Atlas captured the imagination of astronomers long before it neared Mars, we need to place it within the tiny but extraordinary family of interstellar visitors that have crossed our solar system. Until a few years ago, no human being had ever witnessed an object from another star slip through our neighborhood. Then came one Oumuamua in 2017, a silent, tumbling shard that refused to grow a coma and accelerated in ways no ordinary comet should. 2 years later, 2I Borisov followed, this time looking more like the comets we knew, but carrying exotic chemical fingerprints that whispered of places no one had ever seen. And now, we stand at the threshold of a third encounter. 3I Atlas is only the third confirmed object in history to arrive from the deep interstellar dark, cross into the gravity well of our sun, and offer us a brief, unrepeatable window into a place far beyond our reach. The story of its discovery began not with a dramatic flash, but with a quiet alert from the Atlas survey system in Hawaii. Atlas scans the sky for potential hazards, taking wide field images night after night, looking for faint dots that shift from frame to frame. One of those dots was 3I Atlas. Small, understated, almost forgettable. It wasn't until the automated algorithms flagged its motion that astronomers took a closer look. What they found wasn't immediately astonishing. The object's brightness was unremarkable. Its coma was faint but present, yet something about its motion hinted that this was no ordinary visitor. When researchers went back through earlier images, they found it hiding in plain sight, just a soft, wandering point of light that had already been captured weeks before, but never identified. The sky is full of such faint wanderers, so this wasn't unusual. But the more images experts gathered, the more precisely they could chart its path. And from that path, everything changed. The orbit of 3I Atlas wasn't elliptical or circular like the countless comets bound to our sun. It traced an open curve, a hyperbola, stretching from the distant dark and pointing back into it. Such a path means one thing. This object is not from here. It is not gravitationally tied to our solar system. It is a traveler passing through once, accelerating under the sun's pull before escaping forever. Nothing short of interstellar origins could produce such a trajectory. For anyone who studies celestial mechanics, a hyperbolic orbit is like a signature, a cosmic passport stamp. It tells you that the object has spent far more time drifting between stars than it ever will near ours. But 3I Atlas carried another surprise, one rooted not in its origin, but in its destination, because its path through the solar system did something unexpected. It swept through the plane of Mars's orbit, coming close, on cosmic scales, to the very region of space we've spent decades exploring with orbiters, landers, and rovers. To visualize this, picture looking down on the solar system from far above. The sun sits at the center, glowing softly. Earth orbits at one distance. Mars a bit farther out. Their paths form neat circles. Now imagine a long, slanted line slicing across that tidy arrangement from one side of the solar system to the other. That line is the path of 3I Atlas. It wasn't looping gracefully around the sun. It was cutting through like a needle passing through fabric, entering from the outer dark, slipping between the orbits of the planets, then rushing away again. Most comets come in on long, slow ellipses, spending years near the sun and giving us multiple opportunities to observe them. But an interstellar object gives us only one chance. And 3I Atlas happened to take a route that passed through the neighborhood of the one planet we have covered with more observing instruments than any other except Earth. It crossed the orbital plane of Mars, almost like it had booked a one-time flyby and then vanished into the dark. This coincidence is what made astronomers sit up. Interstellar objects don't target planets. They simply follow the trajectories carved by gravity over millions of years. And yet here was a visitor from elsewhere threading its path through a region of space we constantly monitor. The alignment was not perfect, but on the scale of astronomical distances, it was astonishingly close. A few tens of millions of kilometers might sound enormous, but in a solar system measured in billions, it is practically a handshake. Understanding the difference between a native comet and an interstellar one helps explain why this moment matters. Comets born in our solar system carry the chemical fingerprints of the sun's nursery, a blend of ice and dust shaped by the same disk that once formed Earth and Mars. Interstellar comets carry the fingerprints of other suns, other nurseries, other environments. They are fragments of distant histories, pieces of worlds we will never visit. When 3I Atlas entered our space, it brought those signatures with it. And when it drifted across the orbital lane of Mars, it brought them into the view of spacecraft uniquely positioned to gather unprecedented data. Imagine floating above the solar system, watching this encounter unfold. Mars glows in its rusty orbit. Earth follows its blue track. Between them, a fast-moving visitor slices through the darkness, trailing gas and dust shed after millions of frozen years. For a moment, just one, the paths of a distant traveler and our robotic explorers nearly overlap. That moment is the heart of tonight's story. The sense that the universe, enormous and often indifferent, had arranged a brief alignment between something ancient and something built by human hands. The emotional weight of this realization is subtle but profound. A traveler from a star we'll never see up close happened to slip through the one region of space where we've placed our mechanical eyes and ears. It is a reminder of our smallness, but also of our connection to everything else drifting through the galaxy. We did not summon this object. We did not plan its arrival. But we are here at the right time to witness it. And beneath that wonder sits a simple, enticing question. If you designed a flyby to test our instruments around Mars, you'd probably pick a path a lot like 3I Atlas took. The coincidence invites us to look closer, to ask what this object carried with it, and to recognize that its time near Mars was not just another chapter in a comet's life, but a rare chance to study a world-sized laboratory of interstellar material passing through our cosmic neighborhood. Understanding its origin and its one-way path helps us appreciate why the near-Mars encounter felt so special, and why missing any part of it would feel like losing something irreplaceable. And when 3I Atlas stepped onto that Martian stage, it didn't arrive quietly. It brought a coma the size of a world. When 3I Atlas entered the region of space near Mars, it did not arrive as a polite, well-behaved comet gliding quietly past a distant planet. It arrived wrapped in an atmosphere so enormous, so sprawling, so visually overwhelming that even seasoned astronomers admitted they had to blink twice at the processed images. The coma, the vast, ghostly cloud of gas and dust surrounding its nucleus, had swollen to hundreds of thousands of kilometers across. Some estimates placed its full width near half the diameter of the Sun. That is not a typo. Imagine an object with a solid core, barely a few kilometers wide, wearing a cloak as large as a world. To put that into perspective, picture placing such a coma near Earth. If 3I Atlas drifted past our planet with a shroud that size, the faint glow of its atmosphere would stretch across a huge fraction of the sky. You would look up at night and see a diffuse, milky halo cutting across the darkness, brighter near the center, fading at the edges like a fog lit from within. Even without binoculars, the structure would dominate the heavens, a silent, slow-moving veil draped over our world. And this colossal cloud was drifting near Mars instead, turning the red planet into a small ember beside a floating continent of ice and dust. But the coma was not the only spectacle. The real surprise was the tail, or rather, the way the tail refused to behave. For as long as humans have watched comets, some of their features have been almost comfortingly predictable. Dust tails stretch away from the sun, pushed by radiation pressure. Ion tails glow blue and trace magnetic field lines. Even when comets split, or flare, or fade, their tails generally tell us where the sun is. But in many of the images of 3I Atlas, something seemed off. A wide, faint ribbon of dust appeared to angle back toward the sun instead of away from it. It was as if the comet were dragging a long strip of material in the wrong direction. This strange feature is called an anti-tail. Despite the name, it is not truly a tail pointing backward. It is a geometric illusion caused by the way heavier dust particles spread into a thin plane and the angle from which we see the comet. As 3I Atlas rotated, as dust drifted in the plane of its orbit, and as our viewing angle shifted relative to the sun, the spread of particles lined up just right to create the appearance of a backward slanting streak. The physics is not a violation of the rules. It is a reminder that the rules are often more complicated than they first appear. But even so, this anti-tail was unusually crisp, unusually dramatic. It showed up clearly and consistently, as if 3I Atlas were performing a strange, slow-motion trick against the black canvas of space. Now imagine placing this scene beside Mars. Picture a view from orbit around the red planet. Beneath you lies the rust-colored surface, etched by ancient riverbeds and crater rims highlighted by the thin Martian dawn. Beyond the horizon, space darkens quickly. And there, just off to one side, is a vast, shimmering cloud hanging like a pale lantern. Within that cloud, a faint white core glints under the sun's glare, and stretching from it, angled strangely against expectation, is the backward sweep of the anti-tail, a quiet contradiction written in dust. If you were aboard a spacecraft circling Mars, your view would be humbling. The planet below you is a world in its own right, a place with mountains taller than any on Earth and canyons deeper than our oceans. Yet beside this passing visitor, Mars would look small, almost fragile, a tiny red island floating next to a drifting interstellar storm cloud. The contrast feels emotional as much as visual. A young world, the one we dream of walking on again, juxtaposed against a nameless object from far beyond the sun's domain. That striking image raises an uncomfortable question. When we talk about comets having tails, are we truly capturing what these interstellar travelers can do? Or is the language we borrowed from the comets of our own solar system too small, too limited, too Earth-centered to describe something born under another star? a coma spanning hundreds of thousands of kilometers, a backward tilted dust plain, a shifting architecture of gas and particles shaped by forces we barely understand. This is more than a tale. It is a statement, written in light and motion, that not everything drifting through space conforms to our simple categories. The emotional tone of this encounter was an unusual mix, part awe, part unease. Awe, because the sheer size of the coma reminded us of the grandeur of nature. Unease, because it hinted that 3I Atlas might be shedding material faster than expected, pushing itself into a more unstable state. All of it played out on the same stage where Mars orbited quietly, an unintended spectator to a once-in-a-lifetime display. For astronomers, the moment was exhilarating. For spacecraft operators, it was an opportunity. For the rest of us, it is a picture that lingers, a world we long to stand on, watched over by a drifting giant from the dark. And the oddness did not end with the geometry. What made the antitail truly remarkable was its clarity. Antitails have been seen before, but usually as faint, delicate features that take time to tease out of noisy data. The one attached to 3I Atlas appeared clean, sharp, and stubbornly persistent. Even veteran researchers admitted it was one of the more striking examples in recent memory. One expert put it simply, "We've seen antitails before, but rarely this clean and this dramatic, especially from a visitor between the stars." This clarity may have had a deeper meaning. When dust lines up so perfectly, it tells some scientists something about the comet's rotation, its internal structure, and the distribution of particle sizes in its coma. In other words, the antitail wasn't just a visual flourish. It was a clue that this visitor was shedding larger particles in a stable sheet, perhaps shaped by earlier fractures or by an internal layout we cannot yet see. Every image carried information not only about how it looked, but about what it was. As the interstellar traveler swept past Mars, the juxtaposition felt almost surreal. A world we have studied for decades floated alongside a drifting, evolving monument of ice and dust. The terror in the title was not doom or danger, but the sense of scale. The realization that something this large and this alien had passed so close to a planet now surrounded by our robotic explorers. If any of those orbiters managed to turn their cameras inward, toward the drifting cloud, they might have captured one of the most haunting images in the history of planetary science. And then, as if a giant neon sign had been switched on, 3I Atlas began to glow green. Not long after astronomers began marveling at the vast coma and the strangely clean antitail drifting near Mars, another surprise crept into the images. At first it was subtle, just a faint tint appearing in the longer exposures, a whisper of color clinging to the inner coma. Most comets show hints of blue or white depending on the gases they release, but this was different. In the stacked frames from observatories across the world, the heart of 3I Atlas was beginning to blush with a soft, unmistakable green. It wasn't a camera glitch or a processing artifact. It was the comet itself, lighting up like a dim neon sign in the dark. The change happened gradually, then all at once. In early shots, the green tint was almost shy, hiding amid the haze. A few nights later, the glow had intensified enough that even amateur observers noticed. It was the green of carbon molecules, specifically diatomic carbon, or C2, excited by ultraviolet sunlight. When these molecules are exposed to the right energy, they emit a distinctive emerald light. Many comets show it close to the nucleus, but in the case of 3I Atlas, the brightness and uniformity of the glow signaled that something in the comet's chemistry was waking up in a big way. The green color didn't just appear, it blossomed. And it carried a message. To release enough C2 to be visible across millions of miles, pockets of buried carbon-rich material had to be breaking open. These pockets might have been sealed for billions of years, preserved since long before the comet wandered into interstellar space. Now, under the growing heat of the sun, they were venting into the void, bathing the inner coma in a ghostly green light that seemed to pulse with the comet's own internal struggle. For astronomers, this was a thrilling moment, because chemistry tells stories that shapes alone cannot. The sudden arrival of that green glow suggested the comet was peeling back deeper layers of its structure. Combined with the earlier surge in brightness, the implication was clear. 3I Atlas was waking up, shedding shells of its ancient past as it approached the region around Mars. The brightness spike told us energy was being released. The green light told us what the energy was working on. To those of us watching from Earth, the green glow emerged as a soft wash of color in long exposure images. But imagine what it would look like from a spacecraft orbiting Mars. Picture the red planet beneath you, half lit by the sun, half fading into shadow. Beyond the curve of its horizon, the sky darkens quickly, and floating there, quietly, impossibly, is a faint green cloud hovering like a cosmic lantern. The coma glows with pale emerald tones, swirling with hints of white and gray dust. From that vantage point, the comet would look alive, as if breathing. This was the terrifying thing near Mars, not in the sense of danger, but in the sense of witnessing a transformation that feels ancient and unstoppable. That view becomes even more evocative when you think about what lies inside those green molecules. Carbon is one of the fundamental building blocks of chemistry everywhere in the galaxy. But the carbon trapped inside an interstellar object isn't the carbon found in comets from our own solar system. It carries the imprint of a different star, a different nursery of formation, a different history. When 3I Atlas glowed green, it was not merely reacting to sunlight. It was revealing secrets from a place light years away, secrets that had been locked in ice for as long as stars have been shining. The question practically asks itself, what kind of environment forged this chemistry? What pressures and temperatures once shaped the pockets of carbon that were now dissolving into space? And how long had those materials been drifting between the stars before they found themselves near Mars, lighting up like a beacon in our own night sky? As the green intensified, astronomers began to link it directly with the earlier shifts in the light curve. The brightness spike had been the first hint that something inside the comet was changing. The green glow was the confirmation. Together, they painted the picture of a structure undergoing real transformation, like a distant relic being asked to withstand forces it had not experienced since its birth in another star system. The closer it came to the sun, the deeper it opened its layers, revealing chemistry untouched since before the comet ever escaped its home. From a narrative perspective, this is where the story moves from eerie geometry to eerie chemistry. The giant coma and the backward-tilted anti-tail showed us how dramatic 3I Atlas looked on the outside. The green glow showed us that changes were now happening on the inside. Something had crossed a threshold. As one veteran researcher remarked, that green glow is the universe telling you something inside this object has crossed a threshold. For the listener, this moment in the journey invites a shift from apprehension toward wonder. The green is not frightening in the way that danger is frightening. It is frightening in the way that beauty can overwhelm. A reminder that cosmic processes unfold far beyond our control or understanding. Yet the tone is also calming. The color is soft, almost meditative. It transforms the comet from a foreign traveler into a glowing relic that seems to hum with its own quiet energy. Even more intriguing is that the green was not consistent across the coma. It appeared mottled, patchy in some frames, brighter in others. This unevenness hinted at multiple active regions, jets erupting from different parts of the nucleus, each carrying their own chemical signature into the expanding cloud. Some areas were likely venting fresh carbon-rich material for the first time in eons. Others may have been reheating pockets that had been partially exposed earlier in the journey. The result was a shimmering, textured glow that shifted subtly from one observation to the next. Standing back, it is worth imagining what this meant for those operating spacecraft around Mars. They were in a unique position, literally orbiting the very planet that 3I Atlas was passing near at the moment it began this emerald transformation. If any of those orbiters pointed their cameras in the right direction, they could have captured something we have never seen before. A green glowing interstellar object drifting past the red planet, shedding layers of chemistry older than the solar system itself. Like someone turning on a cosmic nightlight near Mars, the glow would have been soft, surreal, unforgettable. This is why the moment feels terrifying in the poetic sense. A chemical memory from another stellar system was awakening beside one of the most studied planets in our own. The timing, the geometry, the chemistry, they all aligned in a way that made the encounter feel planned, even though it was nothing more than the quiet choreography of nature. And just as 3I Atlas was putting on its strangest show near Mars, our own point of view began to fail us. There is a quiet irony in astronomy that every scientist eventually learns to accept. Sometimes, the universe chooses to reveal its most dramatic moments precisely when we are least able to watch. And that is exactly what happened when 3I Atlas reached the most volatile stage of its journey. Just as the coma ballooned to unimaginable size, just as the anti-tail sharpened, just as the green glow intensified, Earth's view began to collapse. Telescopes that had been tracking every twitch of brightness were suddenly forced to stop, not because the comet moved too far, but because it moved too close to the one object we can never look near for long: the sun. In the weeks leading up to this moment, our best instruments had been doing everything they could. The Hubble Space Telescope captured early snapshots, revealing the coma's rapid expansion. JWST studied the dust and gas composition from a safe angle, trying to peel apart the chemistry of an interstellar relic waking up under sunlight it had never seen before. Spherix, preparing for its broader sky survey, gathered what preliminary data it could. Each observatory contributed a piece of the puzzle, and then, slowly but unmistakably, the sun pulled 3I Atlas into a region of sky where no telescope, not even the best we have ever launched, could safely follow. This limit is defined by something called solar elongation. It describes how far an object must be from the sun in the sky before a telescope can aim at it without being overwhelmed or damaged by the sun's glare. For space telescopes, the rules are strict. Hubble has a hard cutoff. JWST must keep its giant sun shield oriented carefully, never risking exposure to direct sunlight. If the target moves inside that protected zone, the telescope must look away, no matter how important the observation might be. And 3I Atlas, in its race around the inner solar system, slipped right into that forbidden zone exactly when it was behaving most dramatically. Ground-based observatories fared even worse. Even if a telescope could technically point near the sun, Earth's atmosphere turns everything into a blinding mess. Sunlight scatters through air molecules, filling the entire region near the sun with a glare so intense that faint objects become invisible. By the time 3I Atlas neared its perihelion, the closest point in its pass around the Sun, it had entered a window of about 4 to 5 weeks during which Earth was almost completely blind. For a world filled with instruments, sensors, networks, observatories, and decades of technology, we suddenly found ourselves unable to witness what might have been the most important chapter of the comet's evolution. The timing was almost poetic. Here was an interstellar object, only the third we have ever seen, undergoing changes that could rewrite what we know about comet physics, and we had to look away. Hubble stopped. JWST stopped. SphereX went dark on this target. From the surface of Earth, even the most powerful telescopes saw nothing but sunlight. Now imagine being a scientist in that moment. You know the object is heating rapidly. You know its brightness has spiked. You know its chemistry is shifting, turning green, venting new materials that have been locked away since before our solar system existed. And yet, for weeks on end, you must sit with only fragments of data, knowing full well that the comet could be splitting apart, erupting, reshaping itself, or changing color in ways we will never see. You know the most interesting details might be happening right now, hidden inside a wedge of sky you are forbidden to look at. This is a special kind of helplessness, not born of danger, but of curiosity denied. It is the feeling of having a mystery unfold just beyond reach. Imagine knowing that something strange is happening in your own neighborhood and having to look away. Scientists describe this period with words like frustrating, humbling, and agonizing, but also with a tone of acceptance. Astronomy has always been shaped by gaps, and sometimes the gaps are where the story hides. And yet, there was one source of hope. While Earth was effectively blind, Mars was not. As 3I Atlas passed near the orbit of the red planet, several spacecraft continued circling Mars, each with its own suite of cameras and spectrometers. If any of them happened to be oriented in the right direction, they might have been able to capture what Earth could not. The idea that somewhere above Mars, a world we've studied with unmatched precision, sat machines quietly witnessing an interstellar object's transformation brought both comfort and tension. Comfort, because the eyes we had placed around another world might save us. Tension, because we had no guarantee they would. Spacecraft schedules are tight. Instruments are often pointed at Mars itself, not outward at deep space. Turning one to watch a fast-moving comet requires timing, coordination, and luck. For the scientists watching the elongation shrink on their screens, the emotional weight of this moment deepened. It wasn't fear of impact or danger. It was the fear of missing reality. Fear of missing a once-in-a-lifetime chance to watch an interstellar body reveal its secrets right beside the most explored planet in our celestial neighborhood. The fear that years from now, we might still be asking, what did we lose in those weeks of blindness? What if the most important chapter of 3I Atlas's story happened while we were forced to look away? This sense of loss is something we can all relate to, even outside astronomy. There are moments in life when we can sense something unfolding just beyond our field of view. Changes in history, shifts in nature, personal turning points we only understand in hindsight. The sky teaches the same lesson, that no matter how advanced we become, there will always be moments we cannot witness. And instead of being a flaw, it is simply part of the experience of living in a universe too vast and too dynamic to fit inside our instruments. One astronomer summarized it beautifully. The most humbling part of astronomy is knowing that some of the universe's best stories unfold while your instruments are offline. This enforced blindness did not quiet the scientific community. If anything, it energized them. Teams began modeling what might be happening behind the sun's glare. Some predicted fragmentation. Others expected volatile-driven geysers. A few suggested that the green chemistry might shift again as deeper layers warmed. Even without direct views, the anticipation grew. The absence of data became its own kind of evidence, a sign that the story was entering volatile territory. And yet, even in that enforced blindness, astronomers were anything but calm. Long before the public heard the name 3I Atlas, long before its green glow reached social media or its giant coma appeared in news headlines, a quieter story was unfolding behind the scenes, inside the inboxes, conference calls, and private Slack channels of the astronomers studying it. To understand why this object felt terrifying, you have to step into that world for a moment. Not the world of formal papers and polished charts, but the world where scientists talk like ordinary people, where uncertainty feels heavy, and where models, the maps they trust, begin to unravel in their hands. On the surface, everything looked calm. Scientific reports spoke carefully about unexpected deviations, enhanced activity, and unusual geometric features. The tone was neutral, as science demands. But read just a few lines deeper into the private exchanges, and a very different tone emerged. Short messages like, "This is weird," appeared between discussions of brightness measurements. Someone else wrote, "The tail geometry doesn't fit cleanly. Are we sure we're not missing something?" Another voice chimed in, "We might be watching something big here." There were group calls where researchers zoomed in from observatories across the world. Slides appeared showing the light curve climbing faster than expected. One scientist pointed out the anti-tail, describing it as cleaner than it has any right to be. Another highlighted the green glow and said, half joking but not really, "This looks like it's waking up from a long hibernation." Around the virtual table, seasoned comet specialists exchanged glances that said more than their careful words aloud. The truth was simple. Their models were breaking down. Not catastrophically, not in a dramatic explosion of equations, but in the quiet way that makes scientists shift in their seats. The numbers didn't line up. The behavior didn't match the predictions. The comet was shedding gas too fast, glowing too brightly, forming dust structures too neatly, and doing it all at exactly the place where an interstellar object passing near Mars would be most noticeable and potentially most informative. If only the instruments could see it. And that is where the unease crept in. It's one thing when a comet surprises you. It's another when it does it near Mars, and you can't quite explain why. Privately, some wondered whether they were watching a slow-motion breakup. Others argued for volatile pockets bursting open. A few asked whether the chemistry of another star system might lead to behaviors we simply didn't have the right tools to anticipate. And floating beneath all of these questions was a deeper worry. Not fear of danger, but fear of ignorance. That feeling when the world stops matching the map you've spent a career drawing. One message captured the mood perfectly. We're not afraid of the comet. We're afraid of realizing how much we still don't understand. Scientists may speak the language of equations and measurements, but they are human beings first. They know what it feels like when a plan collapses. Many of them had spent years building models for how interstellar comets behave based on just 2 previous examples. They thought they had boundaries, guidelines, predictions. And then 3I Atlas arrived and tore through those boundaries like a stone dropped into a calm pond. Not violently, but decisively enough that ripples spread through every conversation. Some of the chatter bordered on philosophical. One researcher typed, "What if this is normal?" What if the universe is telling us our sample size is just too small? Another replied, or what if we're watching an interstellar object fall apart in slow motion? These were not wild guesses. They were the honest attempts of people trying to reconcile models with reality, people who had dedicated their lives to understanding exactly these kinds of objects. The most frustrating part was the timing. As the comet approached the region near Mars, many of the phenomena became more intense. The coma's expansion, the anti-tail's clarity, the green hues deepening. These were the moments astronomers desperately wanted to witness in detail. And yet, Earth's telescopes were being forced to look away. The sun's glare was too bright, the elongation angle too small. Every day brought new signs of activity, and yet those signs arrived through scattered, indirect data points rather than direct images. This added a strange emotional layer to the scientific response. They were not fearful for themselves or for Earth. They were fearful of missing the truth. Fearful that history might record an event of rare beauty and scientific importance, and that we, with all our technology, would be left guessing about what happened. In quiet corners of their private channels, researchers shared this tension. If Mars orbiters miss this, one message read, there will never be another chance. Another wrote, we'll get one passage, one set of conditions, one moment near Mars, and that's it. That sense of finality hung over every conversation. It made the comet's behavior feel bigger than just an astronomy problem. It made it feel like a fleeting moment in a story that would not repeat. The audience for this story, scientists and ordinary listeners alike, could feel it too. The stakes were not existential. They were emotional, intellectual, almost spiritual. This object from another star was telling a story with every flare, every puff of dust, every shift in color, and we were struggling to hear it clearly. For the viewer at home, especially those with memories of broken plans or unexpected turns in life, this part of the story hits deeper. Scientists, for all their knowledge, find themselves facing the same feeling. The moment when the world changes faster than your expectations, when your tools feel small, when your understanding falls behind reality. This is where terrifying becomes something quieter, more personal. Not panic, but humility. And this is why the near-Mars encounter mattered so much. If any of the orbiters around Mars could catch even a brief glimpse, a single high-quality image, it might fill in the gaps left by Earth's blindness. It might preserve a piece of what was happening behind the sun's glare. It might save a chapter that would otherwise be lost forever. By the time Earth looked away, the scientific world was buzzing. Not loudly, not in headlines, but in the private, thoughtful way experts respond when the universe hands them a puzzle they didn't expect. Excitement mixed with doubt, curiosity mixed with a hint of dread, and through all of it, the same question kept returning. What exactly was happening to 3I Atlas near Mars, and could anyone see it at all? So, if Earth had to look away, could Mars become our eyes? When Earth went blind, the story of 3I Atlas did not end. It simply shifted stages. Far from home, circling a world we've never set foot on with human boots, our machines kept vigil. Mars, quiet, red, and ancient, became our best hope of seeing what the interstellar visitor was doing at the very moment it seemed to be changing most dramatically. And around Mars, a small fleet of orbiters continued their tireless circuits, each carrying cameras, spectrometers, and instruments that could, with luck and the right timing, point away from the planet and into the dark where 3I Atlas drifted. There's something surreal about using machines around Mars to watch a visitor from another star streak past. If someone had proposed the idea a century ago, placing automated eyes around another planet just in case a comet from another star wanders nearby. It would have sounded like science fiction. Yet here we were, not by design, but by coincidence, with a set of instruments perfectly positioned for a cosmic rarity. Mars Express, the European orbiter, had already been circling the red planet for years, carrying a sturdy suite of cameras and spectral tools. Its job was to map the surface, study the atmosphere, and keep watch on the dust storms that can swallow entire hemispheres. It was never built to observe an interstellar comet, but it could, if commanded, pivot its instruments toward deep space for short windows of time. NASA's Mars Reconnaissance Orbiter, or MRO, was another potential witness. With some of the most powerful cameras ever sent to another world, MRO typically photographs the Martian surface in extraordinary detail. Rovers, landers, dunes, avalanches, even tiny rocks. But its systems can also stare outward when necessary, watching stars and tracking objects near the planet. Its problem is flexibility. Slewing a spacecraft away from its primary science targets is complicated, requiring power, stable pointing, and careful planning. Then there was MAVEN, designed to study Mars's atmosphere and solar interactions. MAVEN had instruments that could sense dust and plasma behavior, tools that might pick up subtle changes in the glowing coma of a comet. And finally, the Trace Gas Orbiter, TGO, part of the ExoMars program. Its spectrometers could analyze faint gases, potentially detecting the chemical fingerprints of the green glow expanding from 3I Atlas. These orbiters formed a ring of silent sentinels around Mars. The question was whether they could be turned in time. Observing a fast-moving interstellar comet from Martian orbit is harder than it sounds. The orbiters follow strict schedules, passing in and out of Mars's shadow, aligning their antennas with Earth to transmit data, and managing their power and orientation to keep sensitive components safe. To capture 3I Atlas, mission teams had to coordinate, calculate where the comet would be relative to Mars at specific times, determine whether the spacecraft would have line of sight, adjust pointing commands, and ensure the exposures wouldn't saturate or blur from spacecraft motion. The challenges were significant. Long exposures risk smearing the faint coma. Short exposures might miss the subtle green glow. And even if perfect images were taken, the bandwidth needed to send data across millions of miles back to Earth was limited. A single, high-quality image could require hours of precious downlink time. Teams weighed every decision carefully. Still, the effort was worth it, because if any orbiter caught even one clear frame, it could reveal details nobody on Earth could see at that moment. Imagine a high-resolution image showing the green coma billowed like a luminous cloud, faint threads of the anti-tail stretching across the stars. Imagine watching the brightness change night after night, building a record of how the interstellar visitor behaved near perihelion. Imagine seeing the subtle texture of dust jets, or the way the light scattered differently across regions of the coma. Even a few snapshots could rewrite chapters of comet science. Inside control rooms in Pasadena, Madrid, and Darmstadt, the countdown began. Teams prepared commands. Engineers calculated thermal loads. Schedulers slid experimental observations into narrow gaps in the spacecraft timelines. It became a kind of cosmic race against time, an effort to press the button before the comet drifted out of reach or the spacecraft swung behind Mars. The stakes were high, not because of danger, but because of opportunity. This wasn't something that could be repeated next year or next decade. This was a one-time chance to capture images of an interstellar object passing near Mars during its most active stage. The possibility of success filled scientists with a mix of hope and suspense. They imagined what their cameras might see. From Mars Express, a broad, diffused green glow washing across the starfield. From MRO, a sharp, high-contrast streak of dust showing the anti-tail. From MAVEN, subtle signatures in ultraviolet wavelengths hinting at exotic chemistry. From TGO, spectral fingerprints of carbon compounds emerging as deeper layers of the nucleus cracked open. Each orbiter could deliver a different piece of the puzzle. And yet, nothing was guaranteed. The comet could have moved too fast. The alignment could have been off by just a few degrees. One instrument might have been offline. One data link might have been saturated. Even if images were captured, some might be too faint or too blurred to analyze. The scientific teams knew better than to expect a full cinematic sequence. They hoped for only a handful of workable images, enough to catch the essence of the event. Still, the mere possibility was extraordinary. We often imagine space exploration as something active. Rockets launching, rovers driving, astronauts floating in zero gravity. But here, the drama was quieter. It was the drama of waiting, of positioning, of listening through machines we had left around a distant world, hoping they would blink at the right moment. The emotional tone shifted from helplessness to possibility. After the enforced blindness near the sun, this part of the story felt like a breath of relief. Humanity was not entirely in the dark. We had outposts, eyes in orbit around Mars, ready to help. And whether or not they succeeded, their presence reminded us that science is not passive. When the unknown appears, we turn our cameras, adjust our schedules, and try again. We lean toward the mystery instead of backing away. One scientist summed up the collective feeling. If we're lucky, the best footage of an interstellar comet near Mars won't be from Earth, but from machines we left in orbit there. That hope carried the story forward. But while Mars might have been watching, 3I Atlas was already on its way to an even more brutal encounter. There comes a moment in the life of almost every comet when the sky simply swallows it. Night after night, it sinks closer to the sun, edging into a brightness so overpowering that no instrument can follow. For 3I Atlas, this moment arrived just after its most dramatic performance near Mars. One evening, it hung low on the horizon, still faintly glowing green in long exposures. The next evening, it was noticeably dimmer, overwhelmed by sunlight scattering through Earth's atmosphere, and then, almost abruptly, it was gone. Not gone from space, of course, gone from our sight. From the perspective of an observer on Earth, watching 3I Atlas disappear was like watching a ship sail into fog. You could sense its presence even as it faded. You could point to where it must be, hidden behind the glare. But you could not see what it was doing, and you had no control over what happened next. The sun claimed it, and for the next 4 to 5 weeks, the comet's story unfolded behind a curtain of blinding light. During that period, anything could have happened. One possibility was a burst of activity, a sudden surge in jets as deeper layers reached critical temperatures. The comet might have roared to life behind the sun, its brightness spiking again, its coma thickening, its green glow intensifying as new veins of carbon-rich material were exposed. Such outbursts are not uncommon in comets under stress, and 3I Atlas had already shown signs of instability. A second possibility was fragmentation. The nucleus might have split under thermal stress, shedding large pieces that drifted apart like drifting shards of ancient ice. Interstellar comets, having spent millions or even billions of years in the deep cold between stars, can be fragile. Their structural integrity is often tenuous. A sudden crack, a deep internal fracture, or an uneven burst of gas pressure could have shattered 3I Atlas into a fan of fragments. Some might have survived. Others might have dissolved into dust, contributing to the coma without ever being seen as discrete pieces. A third possibility was transformation. The comet might have survived perihelion, but emerged fundamentally altered. Its chemistry could have shifted as volatile layers were exhausted. Its tail geometry could have changed. The green glow might have deepened or vanished. The anti-tail might have sharpened or dissolved. When comets face the full heat of the inner solar system, they often shed parts of their identity. Their appearance before and after perihelion can be so different that only their orbit tells you it's the same object. In all of these scenarios, the timing mattered. Everything that happened behind the sun's glare occurred immediately after the comet's near-Mars encounter. It was as though Mars had served as a prelude, a stage where the first act unfolded in full view before the curtain dropped for the intermission. What came next was hidden not because it was insignificant, but because it was too close to the brightest light we know. The emotional tone of this phase was quiet, reflective, and tinged with something like melancholy. Scientists could estimate where the comet was. They could model the forces acting upon it. They could simulate what might be occurring inside its nucleus. But until the comet re-emerged from behind the sun, none of those models carried certainty. It was a waiting game, a quiet, suspended chapter, a pause between breaths. And beneath that stillness was one lingering question. When it appeared again, would it still be the same comet? Would the vast coma still stretch outward, or would it have collapsed? Would the green glow remain? Would the anti-tail return? Or would the object emerge as a faint husk, stripped of the layers that made it so dramatic near Mars? This uncertainty created a strange kind of acceptance. In the world of astronomy, missing data is not a failure. It's a reminder that the universe schedules events on its own terms. One astronomer expressed the feeling perfectly. In astronomy, missing data is not a failure. It's a reminder that the universe schedules events on its own terms. The sun, in its brilliance, acts as both spotlight and barrier. It illuminates the comet, heats it, transforms it, yet it also blinds us to those very transformations. The most dramatic things the universe does, it often does behind the brightest light we know. As 3I Atlas slipped behind that light, scientists and enthusiasts alike held on to the last images captured near Mars. They pictured the green halo curling outward. They remembered the startling clarity of the anti-tail. They wondered whether those features were still unfolding, strengthening, or collapsing in the heat. Every scenario felt possible. Every explanation felt just out of reach. But instead of frustration, the feeling grew softer. There was beauty in not knowing. There was beauty in the idea that some chapters of a cosmic story simply belong to the universe itself. And when the comet finally reemerged, whatever shape it took, that shape would be a message carried through fire. A message about what it endured and what it lost. Whether it shattered or survived, one thing was already clear. 3I Atlas had joined a very small, very strange family. To see just how strange that family is, we have to sit 3I Atlas next to its predecessors. Before 3I Atlas slipped behind the sun's blinding curtain, before its green glow and giant coma became objects of fascination and worry, astronomers already knew one thing. This wasn't just another comet. It was the third member of a tiny, strange, and surprisingly unruly family. 3 objects from other stars. 3 visitors from the deep dark between suns, each breaking a different rule. each rewriting a different page of the textbook. To understand why the Near Mars chapter of 3I Atlas feels so extraordinary, we have to place it next to its predecessors. 3 visitors, 3 lessons, 3 reminders that the universe rarely behaves the way we expect. The first interstellar visitor, 1I Oumuamua, arrived in 2017. At first, it looked like a typical faint object drifting through the sky, but within days, it became clear that it was anything but typical. It had no coma, no cloud of gas or dust, despite passing close enough to the sun that a normal comet would have been shedding material in visible plumes. Its brightness flickered wildly, suggesting an extremely elongated or flattened shape tumbling chaotically. And then came the most debated surprise, a tiny but definite acceleration that could not be explained by gravity alone. Scientists described it as a non-gravitational acceleration, the same sort of push you see in comets when jets of gas shoot out from their surfaces. But Oumuamua had no visible jets. This combination, no coma, yet an unexplained push, triggered a worldwide debate. Was it a shard of fractured planet? A pancake-shaped fragment of nitrogen ice? An exotic form of hydrogen iceberg? Or, as a few argued, a piece of alien hardware drifting between stars? The scientific consensus leaned toward natural explanations, but the mystery remained. Oumuamua broke the first rule. It didn't behave like anything in our solar system. It was the interstellar stranger that refused to fit any category. Then came the second visitor, 2I Borisov, discovered in 2019. Compared to Oumuamua, Borisov felt like a sigh of relief. It looked like a comet. It acted like a comet. It had a coma, a tail, gas emissions, everything in the textbook. But even Borisov carried strangeness in its chemistry. Its dust grains were unusually pristine, unprocessed by the gentle heating and cooling cycles that solar system comets experience. Its carbon monoxide levels were extreme. Some scientists described it as a comet that formed in a much colder, much more volatile, rich nursery than our own. Borisov broke a different rule. It showed that interstellar comets are chemically wilder than the ones we're used to. They carry signatures of alien star systems, their chemistry shaped by the long-gone stars where they were born. By the time Borisov left the solar system, astronomers believed they had begun to sketch the outlines of interstellar behavior. One visitor with no coma. One visitor with a perfect coma, but exotic chemistry. They expected the third to be interesting, but not overwhelming. Then 3I Atlas arrived, and it didn't just break one rule. It broke several at once. It brightened more dramatically than expected, defying the initial light curve models. Its coma ballooned into a vast sphere the size of a planetary world. It developed an anti-tail so clean and persistent that modelers struggled to explain its geometry. It changed color, turning a turquoise green as deeper, carbon-rich layers ignited under sunlight. It approached the inner solar system faster than either of its predecessors. And most spectacularly of all, it passed close to Mars. Close enough that our orbiters could, in theory, turn their cameras and watch. Placed next to its siblings, 3I Atlas stands out like the youngest child who decided to rewrite the family story. If Oumuamua whispered, "Your understanding is incomplete," and Borisov murmured, "Your chemistry models are too simple," then 3I Atlas practically shouted, "Your expectations are not even close." 3 objects from other stars. 3 different ways of saying, "Your textbooks are not complete." And yet, the most striking chapter belongs to 3I Atlas alone, its near Mars passage. It may have been the first time in human history that an interstellar object wandered through a region of space filled with our own machines. Not rovers or bases or astronauts, but orbiters, silent but tireless, circling Mars every few hours, watching everything around it. That alone places 3I Atlas in a category all its own. We had front row seats around another planet for an interstellar visitor's closest approach. Whether or not those cameras captured anything, the potential itself was extraordinary. This is why scientists felt both excitement and unease. Each interstellar visitor had forced them to rethink something fundamental. And 3I Atlas forced them to rethink several fundamentals at once. It was fast, bright, structurally unstable, chemically complex, and visually dramatic. It did things we had seen before: coma expansion, color change, dust jets. But it did them all more intensely, more suddenly, and at a more scientifically valuable location than any interstellar object so far. Stepping back, the broader lesson becomes clear. Perhaps interstellar visitors are not rare oddities that occasionally pass through our system. Perhaps they represent a diverse population of objects with a range of behaviors we are only beginning to understand. Or perhaps each one is simply unique, shaped by its own history, its own birthplace, its own journey through the cold emptiness between stars. What feels certain is that our sample size is still small. 3 objects, 3 lessons, 3 reminders that the universe is complex, unpredictable, and endlessly creative, and that our role is not to force these visitors into categories, but to follow them with curiosity, even when they confuse us. Especially when they confuse us. When we look back decades from now, the Near Mars chapter may be the part of 3I Atlas that stands out. Not because the comet threatened anything, but because we caught it in the act of misbehaving beside a planet we're exploring. Because we stretched our machines to watch it from afar. Because it reminded us that the universe can still surprise us, in big ways and small. One astronomer summed up the experience simply. Every interstellar object so far has carried one clear message: you're not done learning yet. And so we turn toward the end, not to solve the mystery, but to sit with it gently, to ask a quieter, deeper question. So what do we do with stories like this? Stories that start near Mars and end in mystery? By the time 3I Atlas slipped beyond our view for the final time, the story it left behind was far bigger than its green glow, its impossible tail geometry, or its chaotic bursts of light. It was the story of how a faint speck discovered almost by accident became a mirror, one that reflected our limits, our hopes, and our curiosity back at us. Tonight, as we arrive at the end of this journey together, let's walk back through what we've witnessed, gently, like closing the last pages of a book you aren't quite ready to finish. It began as a dim, easily overlooked smudge on a survey image. Just another point of light among millions. No reason to suspect anything extraordinary. But slowly, night after night, astronomers noticed that it wasn't behaving like a typical comet. Its brightness shifted in ways the models didn't predict. Jets flared, dust spread, and with each new observation, the quiet excitement grew. Something unusual was unfolding. Then came the turning points, the sudden brightening, far more dramatic than expected. The coma swelling until it stretched across hundreds of thousands of kilometers, ballooning into something almost planetary in scale. The anti-tail, sharp and counterintuitive, pointing back toward the sun as though defying intuition itself. And then the color shift, a soft but unmistakable green glow, as if 3I Atlas were lighting a cosmic neon sign in the darkness. All of these events were remarkable on their own. Together, they formed one of the strangest sequences ever seen from a visitor between the stars. And then, as if the universe wanted to ensure the story left a lasting imprint. The most dramatic moments happened near Mars, a world we have been patiently studying for decades, a world we dream of walking on, a world now home to orbiting machines that could, with luck, turn their lenses toward the passing stranger. This was the heart of the title you clicked on, Near Mars. What terrifying thing happened? And the answer, after all this time, is something much more human than catastrophic. The terrifying thing wasn't an explosion or a collision or a crisis. It was the sudden realization of how little control we had. The way 3I Atlas broke our expectations. The way it ignored the models. The way it reminded us that even with spacecraft circling another planet, even with telescopes in orbit and sensors on every continent, the universe still keeps some chapters to itself. Terrifying, in this sense, doesn't mean harmful. It means humbling. It means standing under a night sky that is far older than our species, far wider than our imagination, and accepting that some stories unfold without our permission, beyond our line of sight. The terrifying thing was simply the universe reminding us that we are still beginners here. And yet, if we linger with that feeling, not resisting it, but letting it settle, it transforms. It softens. It becomes something else entirely. Because out of all the planets, out of all the orbits, out of every small world and rocky sphere circling the sun, 3I Atlas happened to pass near the one world where we have cameras ready. The one world where human beings have placed a small network of silent watchers. The one world where curiosity lives in metal and circuits and solar panels. What are the chances? Of all the places in the solar system, this visitor from another star swung past Mars, the planet we have spent decades exploring, dreaming about, reaching toward. You could call it coincidence, but even coincidence, seen through the right lens, feels like an invitation. A reminder that even tiny moments in the cosmos can tie together worlds separated by millions of kilometers. And so we return to ourselves for a moment. Every person listening tonight has lived through their own 3I Atlas moments. Those sudden, unpredictable events that appear without warning, glow brightly for a while, confuse every plan you thought you had, and then move on, leaving you with more questions than answers. Events that feel terrifying while they're happening. Events you don't have the clarity to understand until much later. Events that shape you, not because they were comfortable, but because they weren't. In that sense, this interstellar comet is not just a physical object racing through space. It is a metaphor for the strange interruptions in our own lives. The unplanned, the unexplained, the moments that ask us to pause, breathe, and accept that clarity does not always arrive on schedule. And maybe that's the gift hidden inside the word terrifying. Not danger, not disaster, but a chance to practice something deeper: humility, patience, and curiosity. We live on a small planet orbiting an ordinary star in an ordinary galaxy, and somehow, despite all that ordinariness, we were here, on this tiny blue world, when a messenger from another star system drifted past Mars and wrote a brief, strange chapter across our sky. We were here to notice. We were here to wonder. We were here to ask questions we don't yet know how to answer. Maybe the most terrifying thing is not how strange the universe is, but how beautiful it feels when we finally admit we don't have all the answers. That is the quiet truth the cosmos whispers during nights like this. You don't have to know everything to feel connected. You don't have to solve the whole sky to appreciate its presence. It is enough to witness, enough to wonder, enough to follow the trail of a visitor like 3I Atlas with open eyes and an open mind. And now, as we settle into the final moments of this story, imagine 3-Eye Atlas, far from Mars, far from the sun, drifting back toward the deep dark between stars. Its coma has collapsed. Its glow has faded. Its structure has quieted. It has become a tiny, cold fragment once again, smaller than a city, smaller than a mountain, sliding into distances where human eyes will never find it again. A dot, then a point too faint to track, then nothing at all. But the story remains. It remains in the models that were rewritten, in the scientists who kept watching, in the cameras that turned toward the unknown, in the reminders of how small we are and how lucky we are to be here. And it remains in you, because now you carry this story as well. This is where the journey ends tonight, not with fear, but with gratitude. Gratitude for the sky above you. Gratitude for the questions still unanswered. Gratitude for the strange and beautiful universe that keeps inviting us deeper into its mystery. One astronomer put it simply: the universe is not obligated to be comforting, but somehow, knowing how strange it is makes falling asleep under its sky a little easier. So, take a slow breath. Feel the weight of the day settle. Let the vastness of the cosmos soften your thoughts. You are small, yes, but not alone. The same universe that sends comets between stars also holds you gently in its quiet machinery. Tonight, as you drift off, remember, somewhere out there, far beyond Mars and the sun, 3-Eye Atlas is still moving. Silent, small, and forever reminding us that the story of the cosmos is far from over. Good night.